All right, so I just want to show you the next couple projects. After you get a Linux virtual machine going, so you're ready to do some C programming, then you set up your C environment, and then do this project where you see some stacked frames. So to set up your development environment, you just install this. Now, by the way, I should explain these steps. That'd probably be a good thing to do. The reason you do an update before you do an install is an update does not update the operating system. What an update does is it updates the list of available software. And you always want to do it before you do an install, because if your list of available software is out of date, you will be trying to install an old version of something which might not be there anymore. So make sure you got the latest version of everything. Then this will install Build Essential, which we talked about before. This is the C compiler and a few other things. Multilib lets you compile for hardware different than the actual hardware you're running on. And we're needing that because we're going to make 32-bit assembly code on a 64-bit processor. And GDB is the debugger, which is extremely useful, and we're going to use that a lot to see what's really going on. So this is just going to tell me I've already got all that stuff installed. So now I'm going to make a new directory because I've already got a hello here. Demo 4. All right. All right. So now I can make this file. We've done this pretty much before, but it only takes a minute to do it again. So I use Nano. You can use other editors if you have a graphical environment, but I have only a headless server, and I prefer to, so I get used to using these old techniques. So here we import standard IO libraries. I have my main function. It's going to ask the user what their name is, and then print it out. So if I notice the input name can only be 10 characters long, but it's going to read it with scanf, and the scanf doesn't restrict it to only 10 characters. So you can have a buffer overflow here. So we're going to compile it. Now I'm going to add this switch to avoid having a stack protector, which makes this old-fashioned compilation of more vulnerable code, so we can see how to exploit this vulnerability. And I specified the output file as hello. So if I run hello and give it a name, it's fine, okay. But if I give it a long name, run it again, all right, now I get a segmentation fault. Now this is bad. This means that some data was read or written to an area of memory that is not reserved for the use of this program. It's a fatal flaw, so the program crashed. And that's a buffer overflow because I only had room for 10 characters, and I put in a whole lot more than 10. So to see what happened, we're going to debug it. GDB is the GNU debugger, and Q just makes it in quiet mode so it doesn't print a silly header just getting in the way. So we debug it, and now we can run it in the debugger. And now, one way to exploit this is you put in a repeating string, a non-repeating string rather. I put in A, B, 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 B. All right. Now when it crashes, it tells me where it crashed, and it crashed because notice this address, the 64-bit address, and it ended with something 4545. Now if you know your ASCII, Q, what is minus Q? Q is quiet. So all Q does is avoid printing a big banner. That's all. You don't need it. It just makes the output a little cleaner. And this here is, so this 4545, I spot that, and you will too. That's why you always use capital letters. A is 41 in hex, 65, 4 times 16. So capital A is 41, 42, 43, 44. E is 45. And notice these two 45s at the end, those are the last two E's getting into the instruction pointer. So that's why it crashed. It crashed because I corrupted the address by adding those characters, and I know which input characters ended up in the instruction pointer. So there's a flag you can find here, and we're going to exploit this further as we go ahead. But all right, that's the first little bit. I'm going to stop this recording.